Hello everyone. In this lesson I will solve the ministerial question of lesson 4.3 limits at infinity and horizontal asymptotes. Question number 1. Find the limit when x approach to negative infinity for 3x power 2 minus 2x plus 2 over 3x plus 2x power 2 plus 2. The leading term in the numerator is 3x power 2 and the leading term in the denominator is 2x power 2. Since the numerator and denominator they have the same degree, therefore the answer is the coefficient of the leading term in the numerator over the coefficient of the leading term in the denominator, 3 over 2. Choice C. Question number 2. Find limit when x approach to negative infinity for negative 2x over square root x power 2 minus x equal to limit x approach to negative infinity for negative 2x over square root factorized by x power 2 for the two term in their square root 1 minus 1 over x equal to limit x approach to negative infinity negative 2x. Since x approach to negative infinity, therefore square root x power 2 equal to negative x. Let us do it in two steps. Separate this square root. It will be square root x power 2 times square root 1 minus 1 over x equal to limit x approach to negative infinity negative 2x square root x power 2 equal negative x. Since x approach to negative infinity, if x approach to positive infinity, then square root x power 2 equal to x times 1 minus 1 over x. Reduce x with x and substitute every x with negative infinity. 1 over negative infinity 0, 1 minus 0 0, square root 1 is 1, negative 2 over negative 1 equal 2. Therefore, the right choice is D. Question number 3. Limit x approach to positive infinity for 5 minus 2 over square root x equal to limit 5 when x approach to positive infinity minus limit x approach to positive infinity for 2 over square root x equal to limit any constant number is the same constant minus 2 over square root infinity 2 over infinity 0 equal 5. Choice C. Question number 4. Find limit x approach to positive infinity for 1 half x minus 4 over x power 2. Separate this limit. It will be limit x approach to positive infinity for x over 2 minus limit x approach to positive infinity for 4 over x power 2. Infinity over 2 is infinity minus 4 over infinity is 0 equal to infinity. Choice D. Question number 5. Limit cosine 1 over x when x approach to positive infinity. 1 over infinity 0 cosine 0 equal 1. Choice A. Question number 6. Limit x approach to negative infinity for 12x plus cosine x over 4x plus sine x. Divide both numerator and denominator by x, then limit x approach to negative infinity for 12x over x plus cosine x over x over 4x over x plus sine x over x. X with x, reduce x with x. Limit cosine x over x when x approach to negative or positive infinity is 0. Also, limit x approach to negative positive infinity for sine x over x also is 0 by squeeze theorem. Since cosine x greater than or equal negative 1 less than or equal 1, the range of the cosine divide all sides by x, negative 1 over x, less than or equal cosine x over x, less than or equal 1 over x. Take the limit for all sides when x approach to negative infinity. Limit x approach to negative infinity for negative 1 over x, less than or equal limit x approach to negative infinity for cosine x over x, less than or equal limit 1 over x when x approach to negative infinity. Negative 1 over infinity 0, less than or equal limit when x approach to negative infinity for cosine x over x, less than or equal limit x approach to negative infinity for 1 over x is also 0, named by squeeze theorem. Limit cosine x over x when x approach to negative infinity is also 0. By the same way, limit sine x over x when x approach to negative infinity is also 0. Then the result is 12 over 4 equal 3. Choice B. Question number 7. Limit x approach to positive infinity for 5 cosine x over x equal to 5. Limit 5 cosine x over x when x approach to positive infinity. By squeeze theorem, this limit is 0. 5 times 0 is 0. Choice C. Question number 8. Find the limit when x approach to negative infinity for 5 over x power 2 minus 2 over 3x. Limit 5 over x power 2 when x approach to negative infinity minus limit x approach to negative infinity for 2x over 3 equal to 5 over infinity 0 minus 2 times negative infinity over negative infinity times negative positive infinity, 0 plus infinity. The answer is positive infinity. Choice C. Number 9, limit x approach to positive infinity for 2x power 2 plus 5 over 3x power 2 minus 1. Since the numerator and denominator are the same degree, therefore the coefficient of the leading term of numerator over the coefficient of the leading term on the denominator is the result 2 over 3. Choice C. Question number 10. Limit x approach to positive infinity for 1 minus 3x all power 2 over 6x power 2 plus 1 equal to limit x approach to positive infinity, open this bracket, 1 minus 6x plus 9x power 2 over 6x power 2 plus 1. The leading term is 9x power 2, so the coefficient is 9. The leading term is 6x power 2, the coefficient is 6, reduced by 3 over 2, the result. Question number 11. Find limit x approach to negative infinity for 3 over x power 2 minus x over 2 or 1 half x equal to limit 3 over x power 2 when x approach to negative infinity minus limit x over 2 when x approach to negative infinity equal to 3 over infinity 0 infinity negative infinity over 2 negative infinity negative times negative positive 0 plus infinity equal to positive infinity. Choice C. Question number 12. Find limit x approach to negative infinity for 5 minus 3 over x power 2 when x approach to negative infinity for the constant is the same constant minus 3 over x over negative infinity power to 0, 5 minus 0, 5. The answer is 5. Choice B. Question number 13. Limit x approach to positive infinity for x plus square root x minus 5 over square root x minus 3 equal to limit x approach to positive infinity factorized by square root x square root x plus 1 minus 5 over square root x over also factorized by square root x 1 minus 3 over square root x. Reduce square root x with this square root x. Substitute every x with positive infinity, square root positive infinity, infinity, 5 over infinity 0, infinity plus 1, minus 0 equal to infinity, over 1 minus 3 over infinity 1 equal to infinity. Choice C. Question number 14. Limit x approach to positive infinity for sine x over x by squeeze theorem. The answer is 0. Since sine x is greater than or equal negative 1, less than or equal 1, the range of the sine. Divide all sides by x and take the limit when x approach to positive infinity for all sides. Then we have limit sine x over x when x approach to positive infinity greater than or equal limit negative 1 over x when x approach to positive infinity less than or equal limit 1 over x when x approach to positive infinity. Negative 1 over infinity 0 less than or equal limit sine x over x when x approach to positive infinity less than or equal limit 1 over x when x approach to positive infinity 1 over infinity is also 0. Therefore, by squeeze theorem, the answer is 0. Question number 15. Find limit when x approach to negative infinity for 3x minus 1 over 2x power 2 plus 1 equal to limit x approach to negative infinity factorized by x 3 minus 1 over x for the numerator. For denominator, factorize the 2 term under square root by x power 2. From the first term, we have 2 plus 1 over x power 2 equal to limit x times 3 minus 1 over x over square root x power 2 times square root 2 plus 1 over x power 2 when x approach to negative infinity. Square root x power 2 equal negative infinity when x approach to negative infinity. Equal to negative x when x approach to negative infinity and equal to x when x approach to positive infinity. Therefore, the limit will be limit x approach to negative infinity for x times 3 minus 1 over x over negative x times square root 2 plus 1 over x power 2. Reduce x with x, substitute every x with negative infinity. The result will be for the numerator 3 minus 1 over infinity, negative infinity, 3 minus 0, 3 over negative square root 2 plus 1 over infinity, 2 plus 0, square root 2. Since we have no, in our choices, negative 3 over square root 2, we multiply by square root 2 and divide by square root 2. The answer will be negative 3 square root 2 over 2. Choice C. Question number 16. Find limit x approach to negative infinity for x over square root x power 2 minus x equal to limit x approach to negative infinity for x factorized by x power 2 for the 2 term under square root 1 minus 1 over x equal to limit x over square root x power 2 times square root 1 minus 1 over x when x approach to negative infinity. Square root x power 2 equal to negative x when x approach to negative infinity. Therefore, the limit will be limit x over negative x times square root 1 minus 1 over x when x approach to negative infinity. Reduce x with x, substitute x with negative infinity, 1 over negative infinity 0, therefore 1 minus 0 0, square root 1 1, 1 over negative 1 equal negative 1. Choice D. Question number 17. Find limit x approach to negative infinity for square root x power 2 plus x over negative 2x equal to limit x approach to negative infinity factorized by x power 2, 1 plus 1 over x over negative 2x equal to limit x approach to negative infinity square root x power 2 times square root 1 plus 1 over x over negative 2x. Square root x power 2 when x approach to negative infinity is negative x, therefore will be limit x approach to negative infinity for negative x times 1 plus square root 1 plus 1 over x over negative 2x. Reduce negative x with negative 2x, substitute every x with negative infinity, 1 over negative infinity 0, 1 plus 0 0, square root 1 is 1, 1 over 2 equal 1 over negative 1 over negative 2 equal 1 over 2. Choice B. Question number 18. Find limit x approach to negative infinity for 1 minus absolute value x over x power 2 equal to limit 1 when x approach to negative infinity minus limit x approach to negative infinity for absolute value x over x power 2. Absolute value x equal to x when x greater than or equal 0, negative x when x less than 0. Since x approach to negative infinity, then x is less than 0, therefore the absolute value of x equal to negative x. And the limit of 1 when x approach to negative infinity is 1 minus negative x over, 1 minus limit x approach to negative infinity for negative x over x plus 2 equal to, since the numerator and denominator are the same degree, the coefficient of the leading term in the numerator is negative 1 and the coefficient of the leading term on the denominator is 1, therefore 1 minus minus 1, 1 plus 1, the answer is 2. Choice B. Question number 19. Limit x approach to positive infinity for 1 minus absolute value x over x power 2 equal to limit x approach to positive infinity for 1 minus limit absolute value x over x power 2 when x approach to positive infinity. Absolute value x equal x when x approach to positive infinity, as we see here in the definition. Therefore, the limit of any constant number is the same constant minus limit x over x plus 2 when x approach to positive infinity equal to 1 minus the leading term in the numerator 1, the coefficient of the leading term in the denominator 1, 1 minus 1 equal 0. Choice A. Question number 20. Find limit x approach to negative infinity for 1 minus 2x over square root 4x power 2 plus 1 equal to limit x approach to negative infinity factorized by x 1 over x minus 2 over square root factorized by x power 2 4 plus 1 over x power 2 equal to limit x times 1 over x minus 2 over square root x power 2 times square root 4 plus 1 over x square when x approach to negative infinity. Square root x power 2 equal negative x as x approach to negative infinity. Therefore, it will be limit x approach to negative infinity for x times 1 over x minus 2 over negative x times square root 4 plus 1 over x power 2. Reduce x with x, substitute every x with negative infinity, then 1 over negative infinity 0, 0 minus 2, negative 2 over negative square root 4, 2, negative 2 over negative 2 equal 1. Choice C. Question number 21. Find limit when x approach to negative infinity for 3x minus 2 over absolute value 1 minus x. To find this limit, we need to remove the absolute value. 1 minus x absolute value equal to piecewise function 1 minus x when x less than or equals 0 and negative 1 plus x when x greater than 0. Since x approach to negative infinity, then x is less than 0. Therefore, the absolute value of 1 minus x equal 1 minus x. And the limit will be limit x approach to negative infinity for 3x minus 2 over 1 minus x equal to, since the numerator and denominator have the same degree, the answer is the coefficient of the leading term in the numerator over the coefficient of the leading term in the denominator equal to negative 3. Choice A. Question number 22. Find limit x approach to positive infinity for square root x power 2 plus x over negative 2x equal to limit x approach to positive infinity factorized by x power 2 for the two term under square root 1 plus 1 over x over negative 2x equal to limit x approach to positive infinity for square root x power 2 times square root 1 plus 1 over x over negative 2x equal to, since x approach to positive infinity, therefore square root x power 2 equal to x as x approach to positive infinity. Therefore, the limit will be limit x approach to positive infinity for x times 1 plus 1 over x over negative 2x. Reduce x with x, substitute every x with positive infinity. 1 over positive infinity is 0. 1 plus 0, 1 square root 1 is 1. 1 over negative 2 equal negative 1 over, or negative 1 over 2. Choice A. Question number 23. Find limit x approach to negative infinity for 2x plus 3 over square root 4x power 2 plus 1 equal to limit x approach to negative infinity for factorized by x 2 plus 3 over x over square root factorized by x power 2 4 plus 1 over x power 2 equal to limit x approach to negative infinity for x times 2 plus 3 over x over square root x power 2 times square root 4 plus 1 over x power 2. Square root x power 2 equal to negative x. Therefore, the limit will be limit x approach to negative infinity for x times 2 plus 3 over x over negative x, since x approach to negative infinity, times square root 4 plus 1 over x power 2. Reduce x with x, substitute x with negative infinity, 3 over negative infinity 0, 2 plus 0 is 2 over negative square root 4 plus 1 over negative infinity square 0. 4 plus 0 is 0. Therefore, the answer will be 2 over negative 2 equal to negative 1. Choice B. Question number 24. Find limit x approach to negative infinity for 6x power 2 plus 3x plus 2 over 5 minus x. To find this limit, remove the absolute value 5 minus x equal to piecewise function 5 minus x when x less than or equal 0, negative 5 plus x when x greater than 0. Since x approach to negative infinity, therefore x is less than 0. The absolute value of 5 minus x equal 5 minus x. The limit will be limit x approach to negative infinity for 6x power 2 plus 3x plus 2 over 5 minus x. Since the power of the numerator greater than the power of the denominator, the answer will be 6 times negative infinity square is infinity. Therefore, the result is positive infinity. Question number 26. Find limit x approach to positive infinity for cosine 1 over x plus 1. Substitute x with infinity 1 over infinity 0 cosine 0. Cosine 1 over infinity plus 1 cosine 0 over infinity 1 over infinity equal 0. Choice B. Question, we skip 25. Let us solve 25, then we solve 27. Find limit x approach to negative infinity for negative 2x power 2 plus x plus 2 over absolute value 1 minus x is similar to 24. Remove the absolute value 1 minus x inside absolute value equal to 1 minus x when x less than or equal 0, negative 1 plus x when x greater than 0. Since x approach to negative infinity, therefore the limit will be limit negative 2x power 2 plus x plus 2 over 1 minus x when x approach to negative infinity. The power of the numerator greater than the power of the denominator. The answer will be negative infinity square, infinity times negative 2, negative infinity. Choice C. 27. Which is wrong for the following limits? For the first limit, limit x approach to pi over 4 tan x over 4x is true since tan pi over 4 times pi over 4 equal to tan pi over 4 is 1. Reduce 4 with 4, the result is 1 over pi. It is true. For the second one is also true since absolute value x minus 3 equal to x minus 3 when x greater than or equal to 3, negative x plus 3 when x less than 3. And since x approach to negative 1 is less than 3, we substitute every absolute value x minus 3 with negative x plus 3. Therefore, the limit will be limit negative x plus 3 over x minus 3 when x approach to negative 1 from left equal to negative 1 plus 3 over negative 1 minus 3 equal to 4 over negative 4 equal to negative 1. Choice C is also true since Let us solve it here. Cosine 3x over x multiply by 3 and divide by 3. Therefore, 3 limit cosine 3x over 3x when x approach to positive infinity equal to 3 times 0. Since limit cosine 3x over 3x when x approach to positive infinity is 0 by squeeze theorem, the answer is 0. Therefore, also C is true. Let us check D. It is wrong since the result is positive infinity. Limit 2 over x plus 1 when x approach to negative 1 from right equal to positive infinity. Since if we substitute every x with a number greater than negative 1, then the limit will be 2 over 0, negative 0.9 plus 1 equal to 2 over 0.1, and this value is positive. And if we find numerically these limits, we found that the limit approach to positive infinity when x approach to negative 1 from right for this function. Question number 28. Find limit x approach to negative infinity for 3 minus x over square root 4x power 2 plus 25 equal to limit x approach to negative infinity for factorized by x 3 minus x 3 over x minus 1 over square root factorized by x power 2 for the two term under square root 1 over 4 plus 25 over x power 2 equal to limit x approach to negative infinity x times 3 over x minus 1 over square root x power 2 times square root 4 plus 25 over x power 2 equal to limit x times 3 over x minus 1 over square root x power 2 equal negative x, since x approach to negative infinity, times square root 4 plus 25 over x power 2. Reduce x with x, substitute every x with negative infinity, 3 over negative infinity 0, 0 minus 1, negative 1, over negative square root 4 plus 25 over infinity 0 equal to negative 1 over negative 2 equal to 1 half. Choice B. Question number 29. Find limit x approach to negative infinity for 2x power 2 minus x minus 1 over x minus 2. Remove the absolute value by the definition x minus 2 equal to x minus 2 when x greater than or equal to and negative x plus 2 when x less than 2. Since x approach to negative infinity, it is less than 2, therefore absolute value x minus 2 equal to negative x plus 2. And the limit will be limit x approach to negative infinity for 2x power 2 minus x minus 1 over x negative x plus 2 equal to, since the degree of the numerator greater than the degree of the denominator, the answer is negative infinity power 2, infinity times 2, infinity. The answer is positive infinity. Choice B. Question number 30. Find limit x approach to positive infinity for sine 2x over 3x multiply by 2 over 3, limit x approach positive infinity, sine 2x over 2 over 3 times 3x. Reduce 3 with 3. The answer will be 2 over 3, limit x approach to positive infinity, sine 2x over 2x. By squeeze theorem, limit sine 2x over 2x when x approach to positive infinity is 0, then 2 over 3 times 0 equals 0. Choice A. Question number 31. Find limit x approach to positive infinity for 1 plus ln x over x equal to limit x approach to positive infinity for 1 plus limit x approach to positive infinity for ln x over x. Length any constant number is the same constant plus limit ln infinity is infinity over infinity. Therefore, we can use L'Hopital rule since the limit equal infinity over infinity. Differentiate limit ln x over x when x approach to positive infinity equal to limit x approach to positive infinity, differentiate ln x 1 over x, differentiate x1, substitute every x with infinity, 1 over infinity 0. Therefore, this limit equal 0, 1 plus 0 equal 1. Choice C. See you next lesson.